This is general chemistry. Today we will be looking at stoichiometry and mole. Stoichiometry is a big topic in chemistry. It usually focuses on the relationships between reactants and products in chemical reactions. For example, in a chemical reaction between magnesium metal and hydrochloric acid to produce magnesium chloride salt and hydrogen gas. Using stoichiometry, we can figure out how much magnesium metal is needed to produce a certain amount of hydrogen gas. And also the other way around, we can figure out how much hydrogen gas can be produced from a certain amount of magnesium metal. And for this example, is a thermal decomposition of potassium chlorate into potassium chloride and oxygen gas. Using stoichiometry, we can figure out how much potassium chlorate is needed to produce a certain amount of oxygen gas. And also the other way around, we can figure out how much oxygen gas can be produced from a certain amount of potassium chlorate. But before we dive into stoichiometry and this chemical reaction in detail, we will first need to understand the fundamental basic of stoichiometry. And we will start with mole. So what is mole? Mole is simply a way to represent a specific number of things. Actually, we already knew many terms that are used for a certain number of things. For example, couple means two things. Pair also means two things. Dozen means 12 things. And a grand means 1,000. And for mole, it means 6.02 times 10 to the 23rd things. And that is quite a big number. Well, that's why we have the term mole to make it more convenient. And this big number 6.02 times 10 to the 23rd is sometimes called Avogadro's number or Na. The term mole can be used in many different situations. For example, we can use it with atoms. Let's say we have 1 mole of sodium atoms. It means we have 6.02 times 10 to the 23rd of that sodium atoms. Mole can also be used with molecules. And if we have 1 mole of water molecules, it means we have 6.02 times 10 to the 23rd of the water molecules. And if we have 10 moles, it means we have 6.02 times 10 to the 24th of the water molecules. So mole is just another way to represent a specific number of things. But it happens to be a central unit in chemistry too. Mole can be related to many other quantities, so it is useful to know how to convert between them. We actually knew a little bit of this already from the last examples. We knew how to convert between mole and the number of atoms or molecules. Later, we will learn how to convert between mole and mass, and also between mole and volume in the case of gas, and finally between mole and concentration in the case of solution. Let's focus first on the number of atoms or molecules. In order to convert between number of atoms or molecules and mole, we can use this conversion. If we are dealing with atoms, mole will be equal to the number of atoms divided by 6.02 times 10 to the 23rd. And if we are dealing with molecules, mole will be equal to the number of molecules divided by 6.02 times 10 to the 23rd. Or we can say the little n, which is mole, is equal to the big N divided by Na. The big N is number of atoms or molecules, and the Na is Avogadro's number, or 6.02 times 10 to the 23rd. Now let's try some practice questions. This one asks how many moles of aluminum are there in 3 times 10 to the 25th atoms of aluminum. We know that N or mole is equal to big N over Na. So since they're looking for moles, we can just plug in the number. Here we will have 3 times 10 to the 25th atoms. divided by 6.02 times 10 to the 23rd of atoms per mole. And if we approximate 6.02 to be 6, we can cross this and this will be 2. So we will get 0.5 times 10 to the power of 2, and that is gonna be about 50 mole. And that is the answer here. The next question asks how many molecules of methane are there in 2.5 moles of methane. Again, we know that little n is equal to big N divided by Na. They ask for the number of molecules, which is the big N. So we can convert this into big N equal to little n times Na. And that's gonna be equal to 2.5 mole multiplies 6.02 times 10 to the 23rd of molecules per mole. Okay, if we approximate 6.02 to be 6, we can get 2.5 times 6, which is going to be 15 times 10 to the 23rd, or 1.5 times 10 to the 24th molecules. And that is the answer here. Now let's try taking a look between mole and mass. In order to convert between mass and mole, we can use this conversion. N, which is mole, is equal to mass in grams divided by molar mass in gram per mole. Just be aware that instead of molar mass, sometimes they might use molecular weight or molecular mass. These terms are sometimes used interchangeably, so it's even no point to try to differentiate between them. As long as you stick with the unit gram per mole, you are good to go. For the abbreviated version, we can say N or mole is equal to little m divided by big M. Little m is the mass in gram and big M is molar mass in gram per mole. Now let's try taking a look at some practice questions. For this one, they ask how many moles of copper are there in 2.542 grams of copper. We know that little n or mole is equal to little m or mass divided by big M or molar mass, and that's gonna be equal to 2.542 grams divided by 63.55 gram per mole for copper, and you can get this from periodic table, and that's gonna be equal to 254.2 divided by 6355. I think we can divide it by 31, and that's gonna give us 8 here, 2 here, and that should be 205. And then I think we can divide it more by 41, and that should be 0.2, and then that should be 5. Alright, so we get 0.2 divided by 5, and that should be 0.04 mole, and that is the answer. If you're not comfortable doing this in your head, then just plug into the calculator. That should work too. So the next question asks, what is the weight of 0.004 moles of aspirin? Again, we know that little n is equal to mass divided by molar mass. And since they're asking for the weight or mass, which is little m here, we can convert this into little m is equal to n times big M. And big M is the molar mass of the aspirin, and we can get it by using information from the periodic table. For C9, it's going to be 12 times 9. For H8, it's going to be 8. And then for O4, it is going to be 16 times 4. Alright, and then that should be about 108 plus 8 plus 64. And that is going to be 180 grams per mole. Now we can plug it in. So mass here gonna be equal to mole which is 0.004 mole multiply 180 gram per mole, and that is going to be 0.72 grams, and that is the answer here. Now let's try taking a look between mole and volume, and that will be for the case of gas. In order to convert between volume and mole, we will consider two situations. First, we will consider gas at STP or 0 degrees Celsius and 1 atm. At STP, any ideal gas pretty much has a volume of 22.4 liter. So the conversion to mole for this case is pretty straightforward. We can use mole will be equal to volume in liter divided by 22.4. Or little n, which is mole, is equal to V divided by 22.4. But if the gas is not at STP, then we have to take into account pressure, volume, and temperature. And mole will be equal to PV over RT. P is the pressure in atm, V is the volume in liter, R is a gas constant, and T is the temperature in Kelvin. To understand this better, we should try some practice questions. This first question is for gas at STP, and it says how many moles of carbon dioxide gas are present in 3.36 liter at STP. As mentioned earlier, when it's at STP, the conversion is pretty convenient. We can use N equal to volume divided by 22.4, and that is going to be equal to 3.36 liter divided by 22.4 liter per mole, and that is going to be equal to 3.6 divided by 2 to 4. I think this can be divided by 112. Yes. And then that should be 0.3. And then that should be 2. And then the answer is going to be 0.15 mole. The second question is for the gas not at STP. It says how many moles of ethane gas are present in 12.3 liter at 27 degrees Celsius and 1 atm. Since it is not at STP, we have to use N equal to PV over RT. P is 1 atm. And then V is going to be 12.3 liter. And the whole thing is divided by R, which is 0.082 liter atm per mole Kelvin. Alright, and then T, which is 27 plus 273, and it's going to be 300 Kelvin. we can divide this by 3. It's gonna be 100. And this by 3 is going to be 4.1. And then I will multiply this by 10. It's going to be 41. And this by 10 as well. It's going to be 0.82. And then I'm going to divide this with 41, so it's going to be 1. And this with 41, so it's going to be 0.02. And then that's going to make things much easier. So it's going to be 1 divided by 0.02 times 100. And that is going to be 1.1/2, and then that is going to be 0.5 mole, and that is the answer here. Again, if you are not comfortable doing this in your head or not comfortable with my math, you can plug in the calculator or do it your own way, as long as we can get the answer here. Now let's try mole and concentration, and that is going to be the case for solution. For concentration, we will try taking a look at 2 cases. First, we will look at the concentration in molar or mole per liter. And in order to convert that into mole, we can use this conversion. Mole is gonna be equal to molar concentration times liter of solution. And for the second case, it's gonna be between concentration in molal or mole per kilograms and mole. In order to convert the concentration in molal into mole, we can use this conversion. Mole will be equal to molal in concentration multiplies kilograms of solvent. Be careful though, there's a key difference here. Molar at the top part is dealing with liters of solution, but molal at the bottom part is dealing with kilograms of solvent. Alright, let's try taking a look at some practice questions. For this one, it asks to calculate the molarity of 250 milliliter solution containing 108 grams of glucose. Alright, we know that N is equal to molar times liter of solution. Okay, so we have molar is going to be equal to N, which is mole divided by liter. Okay, and liter we know it gives us 250 milliliter, but mole we don't know, but we can calculate it. It's from glucose, which is C6H12O6. And since we know that mole is equal to mass divided by molar mass, and mass we have 108 grams, but for the molar mass we can calculate it. It is going to be, for C6 it is 12 times 6. For H12 plus 12, for O6 it is 16 times 6, and it is going to be, it is 72 plus 12 plus 96, so it is 180 grams per mole. So we can plug it back in here, 180 grams per mole, and it is going to be 0.6 mole. Okay, now we have this. We can plug it back into the original formula. So it's going to be mole, which is 0.6 divided by 250 milliliter, but it is liter, so it has to be 0.25 liter. So the molar is going to be 2.4 molar. And that is the answer. For this next question, it asks, calculate the molality of a solution containing 5.4 grams of urea in 300 grams of water. So this time it is the second case, which is molal. That's alright. We also know that N, which is mole, is equal to molal times kilograms of solvent. So since they're looking for molal, it is going to be equal to N, which is mole, divided by kilogram of solvent, which is water in this case. And we don't know N yet, but we know water. It gives us in 300 grams. And for mole, we can calculate it. It is for urea, which is NH2CO or N2H4CO. Definitely easier to look. And now we also know that N, which is mole, gonna be equal to mass divided by molar mass. For mass, it is 5.4 gram. And for molar mass, it is going to be, let's see, N2 gonna be 14 times 2 plus H4, it is going to be 4 plus C1, pretty much it is going to be 12 plus O1, which is 16. So that is 28 plus 4 plus 12 plus 16. It is going to be 60 gram per mole. N is equal to M over M. The little m is 5.4 grams divided by big M, which is 60 gram per mole. And that is going to give us 0.09 mole. Now that we have mole, we can plug it back into the original formula. And that is going to be 0.09 mole divided by 300 grams of water is going to be 0.3 kilograms. And then molal, it is going to be 0.3 molal. And that is the answer. So let's try to summarize what we learned so far in this video. We learned a lot about mole. We also learned how to convert between mole and other quantities. To convert between mole and the number of atoms or molecules, we can use mole equal to big N over Na. And to convert between mole and mass, we can use mole is equal to little m divided by big M. And to convert between mole and volume for gas, we took a look at two cases. If the gas is at STP, we can just divide the volume by 22.4. But if the gas is not at STP, we will use PV over RT. And to convert between mole and the concentration for solutions, we also have two cases. If we are dealing with molar concentration, we can multiply molar concentration with liters of solution. But if we are dealing with molal, we can multiply molar concentration with kilograms of solvent. I know it's a lot of information, but mole is an important concept and you need to practice to get comfortable with it. As I mentioned earlier, stoichiometry is a big concept, but it's really important in chemistry. You can apply this into many other topics and branches of chemistry. Again, practice more until you are comfortable with this. You may go over this video again at your own pace, and good luck!